Hi everyone, in this video we're going to be showcasing the new innovative software solution to measuring cross sections on the Fulcrum. So the typical problem with manual machines when measuring cross sections of turned components just like this one is that there's no way to lock off the axis. So when we try to scan the cross section, because we can't be exactly on the center line of the part, the measurements are no good and can't be used. However, this new projectional scan option within the software solves this problem, and it makes it very easy to measure cross sections just like this on the Fulcrum. So let's have a look at how it works. So I already have the plane and circle measured on the component, so all I need to do now is make sure that I am in scanning mode, make sure the probe is switched on, and then open up a curve feature. We're then going to tap at the start, continue moving the stylus over the cross section. Doesn't matter if we stay on the center line or not, the software will take care of that later, and at the end we pause. That completes the curve measurement. Now we have the curve measurement, we now need to project the points through a sectional projection. So this is the new innovative software feature that allows us to measure this okay. So right click on the curve, and at the moment it's just a bunch of random points, but if we select the projection plane here, then select measured and left click or select on the center circle, the software will ask us, do you wish to use a sectional projection? If we click yes, it will then ask us if we want to update the template. We'll click yes, and you'll see immediately there in the view, it now matches up the sectional projection in which we scanned. So even though we weren't on the center line, the software was able to fit the points to a sectional projection best fitted to this circle. So no need for any axis locks. It's a very innovative software solution. So now, just like any other feature, if we hit the green tick and we go to the XZ view, you'll see this is a bunch of data points which we can then construct the individual features and dimension them. So to do this, it's just a simple process of selecting the feature you want to construct, hit the construct button, and then either individually pick points and it will draw the line out here, or we can select the feature and drag a box around the points that we want to use to construct that feature. You can do this for any number of features. You'll see here I'll do this for the radius, and the idea is we can now select these features and measure them where we previously couldn't get any dimensional data for them. So very useful, and now we can effectively measure cross sections of turned components without the need for any axis locks. As a last step, just an additional benefit of the Abling 3D software package, and we can import DXF. So this is a perfect option for this. So when we've done the cross-sectional scan, instead of constructing all the individual elements, it's often required that you can actually do a profile check to the DXF. So with the Fulcrum, we go to Settings, click on the Import DXF button here, and then select the DXF. You have the option for importing as an inspection template or a curve profile. For this we're going to use curve profile. So click next, select the plane that it's projected into, so we're using the XZ view, hence it being selected here. You can change this depending on your application. We have units, default tolerance, and whether you want to round the corners or not. So I'm happy with all this, I hit finish. Just close that. So this DXF fit window allows us to nudge the DXF around like so. We can also rotate it, or if you press the mouse wheel in, you can offer the DXF up roughly to where you think it should be, and then if you press play, the software actually does a best fit, and there we go. So we can see there any points that we've scanned that are inside the tolerance zone. So the red is the DXF, the grey is the plus or minus 50 micron tolerance zone. You'll see any that are in are green, any that are out. So it looks like there's a little bit of a bump here on the chamfer, You'll see everything else fits in okay, and that's how we do a profile check to a DXF from the scanned cross-sectional data. See, at the end the idea is we can dimension the curve and we get a profile call out to make sure it's within spec. So that is DXF comparison with the cross-sectional scan.